Hi guys, welcome to the post-contest discussion of the Code Forces Round 1009. And this is Abhinav. And before starting, let's discuss a little bit about the newly launched second version of the CP31 sheet. In this sheet, you can see there are problems from rating 800 up till 1900, sorted by rating 31 problems from each rating. Okay, and these problems are handpicked, which every problem teaches you a unique idea. So do check it out and must try. Along with that, you can see that in the YouTube channel of TLE Eliminators, we'll be releasing solutions of 7 to 8 solutions every week from the CP31 sheet. The solutions are already, a lot of solutions are out. So if you get stuck, you can watch those solutions. And there's also a feature to connect your code forces handle. You can connect it and all your progress from your code forces handle would be fetched into this sheet. So it's a great way to practice, and do check it out. The link for this would be in the description of this PCD. Okay, so let's start with the PCD from today. Okay, so today we'll discuss the first 6 problems from the Div 3 contest. Okay, let's start with the first problem, which is draw a square. Okay, so in this problem, you are given the 4 distinct points on a plane, and these points are minus L comma 0. Okay, so you are just given 4 positive integers L, R, du, which represents just 4 points: minus L comma 0, R comma 0, minus D comma 0, and U comma 0. So likewise, you form a basically with these 4 points, you want to form a square. Okay, so you have to just determine, is it possible to form a square with these 4 points? So basically, you are just given 4 positive integers L, R, D, and U, which just represents the 4 points in the coordinate axis. And these points are, this is minus L comma 0. This is one of the point. Okay. And then R comma 0 is one of the point. Then 0 comma U is one of the point, and 0 comma minus D is one of the point. So with these 4 points, whatever figure you form with these 4 points, okay, you have to determine whether this figure is a square or not. Okay, so like just by looking, you can say when would this figure be a square. Okay, the figure formed by these 4 points, when would this be a square? Obviously, when this distance, this distance, this distance, and this distance, all the 4 are equal, then only it could be a square. Okay, for it to be a square, this length should be equal to this length, should be equal to this length, should be equal to this length, and all of them should be 90 degree. So it would be only possible when all of these 4 lengths are equal. That is, L is equal to R, is equal to D, equal to U. That's the main condition. Just by looking also you can figure out, or even if you want to prove it mathematically, then this length would be like this square plus this square. So it will be L square plus U square. This length would be L square plus D square. So likewise, if you equate all the 4, finally what you would get is L equal to R is equal to U equal to D. Okay, so this is the condition that you just need to check. If all of these 4 input variables are equal, then you answer a yes, otherwise you answer a no. That's all that you need to do in this problem. Okay, so if you look at the code, just take the 4 input. If L is equal to R and R equal to D and D equal to U, that means all the 4 variables are equal, then you print a yes, otherwise you print a no. Simple. And its time and space complexity, both of them would be O of 1. You are just simply printing with an if else. Okay, so I hope this problem is clear. We can move on to the next problem now. Okay, so let's move to the next problem, which is the third side. The pink soldiers have given you a sequence A consisting of n positive integers. You must repeatedly perform the following operation until there is only one element left. Okay, so you are given an array A of size n, and you need to perform some operations. So choose 2 distinct indices I and j. Then choose a positive integer x such that there exists a non-degenerate triangle with the side lengths ai, aj, and x. Okay, so we'll discuss what does that mean. Finally, remove two elements ai and aj and append x to the end of a. So after performing this operation, you need to repeatedly perform this operation again and again until there is only one element left in the array. And you just need to find how you would optimally perform the operation so that that final element which is left is maximum. You need to maximize that final element. Okay, so n is given to e5. So you need to solve this in order of n or n log n max. So what the problem states is you are given an array A. Okay, so basically you are given an array A of size n. Okay, and what you need to find is in every operation what you can do, you select any two indices, basically just select any two values from the array. Okay, let's say you selected this I and j, any two values. So here you have ai, you have aj. Okay, so you got two values ai and aj. After that, once you have selected two values, then you need to select any arbitrary integer x. Okay, the range of x should be just you have to select any x, any positive integer x. And what that should satisfy is this value x and the two values from the array. You have selected two I and j, the value at those indexes ai and aj. These three should form a non-degenerate triangle. What does that mean? That means what's the condition for the three sides to be a triangle? A plus b should be greater than c, a plus c should be greater than b, and b plus c should be greater than a. Okay, so that means ai plus aj should be greater than x, ai plus x should be greater than aj, and aj plus x should be greater than ai. Okay, so you need to select such an x which satisfies these three conditions. And after that, what you do is you just remove these two values from the array and append this x at the end of the array. Okay, so this way with every operation you are removing two values and inserting one value. So the size of the array is always reducing by one in every operation. So if you have a size of n, so after n minus 1 operations, your size would become 1. And whatever element is left at the end, you need to maximize that. Okay, so how do you do that? Like, for example, if you just take this test case. So you have this array. What you can do is, let's say you selected this I and this j. Okay, so 4, 5, and then you need to select an x so that it satisfies the condition of a triangle. Okay, let's say you selected 8, x as 8. So it satisfies this condition. 4 plus 5 is greater than 8. 5 plus 8 is greater than 4. 4 plus 8 is greater than 5. So you can select 8. Then what you can do, you can remove 4, you can remove 5 and insert 8. Okay. Likewise, next, let's suppose you selected 3 and 8. Okay. And then you can select some x. Likewise, when you do, for this, the best answer was you can reach 11 at the end. Okay. So now let's try to analyze and find out how we can optimally form the best answer at the end. So first, let's see this condition. If you have a if you have two values, what is the third value? What all possibilities of this x can we have which satisfies these three conditions? Okay, so first thing is, for a triangle to be degenerate, there are three conditions, but you can actually write these three conditions into a single condition that if you have three values, whichever is the maximum value. Let's say you have three values. Let's say you sort these three values, and whichever maximum values I am telling as mx, other two values are, let's say, y1 and y2. Okay, then your condition is y1 plus y2 should be greater than mx. If this one condition is satisfied, all the three would be satisfied. Basically, among the three, when you keep the maximum element to the right side, then if this condition is satisfied, the other two would also be satisfied. It's quite obvious, because like if you have three elements, let's say you want to check this. Okay, if you have the maximum element in the left side, then that maximum plus anything else would obviously be greater than the other. So the other two conditions are irrelevant. Only relevant condition that you need to check is the two smaller elements, the sum of them should be greater than the maximum element. That's the only relevant condition. Okay, once you know that, now if you are already given two values, let's say if you are already given two values y1 and y2, what is the third value that I can choose? Okay, first is, let's say the smaller of y1 is the smaller of the two and y2 is the greater of the two. Okay, so either your x is, let's say, less than y1. If I am choosing an x less than y1, then it should satisfy the condition of x plus y1 should be greater than y2. Okay, this gives up the condition that x should be greater than y2 minus y1. Okay, if I'm choosing in this range. Okay, or maybe I can have my x in between y1 and y2. Then also this y2 would be greatest, so x plus y1 greater than y2. Same condition is there. So then also we get x greater than y2 minus y1. This should be satisfied. Okay, or I can have x greater than y2. So if I have x greater than y2, it should satisfy y1 plus y2 should be greater than x. Okay, that means we got x should be less than y1 plus y2. Okay, so if you merge these two, then what is the range of x that we get is the difference of the two values to greater of the two values. So x should be in the range of excluding them. Okay, so the maximum value of x that I can take, if you have two y1 and y2 to form a degenerate triangle, the maximum value of x I can take is y1 plus y2 minus 1, you can say. And the minimum value I can take is y2, the difference of the two, plus 1. Okay, so x has to be in this range. That's one conclusion. Now, what I want to do here, what I want to do is select any two values, remove them and replace them with x. Okay, so you want to maximize the final value. So if you are removing two values and replacing them with some value, okay, again you are removing two values, replacing with some values. Finally, at the end, when you are left with two values, you replace them and replace with that last single value, which should be maximum. So it would be always like greedily, you can understand, it would be always best to take the maximum value of x that you can take. Okay, because we would always replace this with the maximum value of x, and further, when this x get replaced, then they would act as a y for some other value. So this sum of y1 y2 would also increase. So it would always be greedily best to always select the maximum value, which is y1 plus y2 minus 1. So basically always you are replacing x with y1 plus, or you can say ai plus aj minus 1. So you select two values, replace them with this. Okay, so how would that happen? Let's say you have a1, a2, a3. Okay, let's say you selected any two values, an minus 1 and an. Okay, and then you would replace these two values with what x you would take? You would to take the sum of them minus 1. Okay, so they would be replaced by this. After that, maybe you have some value an minus 2. So then you would take this value and this x. Okay, replace with the new x would be an minus 2 plus this, the previous x that you had replaced it with, minus 1. Okay, then again this thing would be replaced by another an minus, like would be taken along with another an minus 3 and replaced by x. Okay, so basically what you are getting the sum of all the values. So your final, by doing this, your final value would be just sum of all these n values and minus 1 minus 1 minus 1 every time. So for n minus 1 values, always you would get a minus 1 minus 1. So that is the like maximum sum you can get. So I hope now the problem is clear. What you needed to print finally was the value of the last element. So if you perform the operations like this, and then the order of the elements doesn't matter, just take any two elements, replace them with the sum of them minus 1. Okay, so that way, if you just perform the operation on the whole array and you get your final value. Um, is there any doubt in this? Someone was telling to repeat. Did you get it or? Yeah. So final answer you can say is sum of all the elements minus n minus one times you are performing the operation every time you get a minus one. Okay. So it's sum minus n plus one. This would be your final answer. You can directly calculate the sum and write like this, or maybe you can just perform the operation also if you're unsure about the formula. Um, yeah, in test case 3, you can see sum is 9, 3, 12, and 3, 15. Okay, so 15 minus 4, 15 minus n minus 1, 4, you get 11. You can verify them in the test cases. Your final answer would always be sum minus n plus 1. Okay, so here the sum was 15, minus n is 10, plus 1 is 11. This also you can just do the sum and subtract 2 with it. You will get this. Okay. Even if this formula is not clear, like you can always do O of n, n is 2e5 only. So you can just perform the operations as it is given. Just select any, let's say you just from the array, just select the last two elements, replace them with their sum minus one. Select the last two elements, replace them with sum minus one. Select last two and replace with sum minus one. Okay, so if you are not deriving the formula, you can just do it manually like that and you will get the final element. That would also be O of n only. And for calculating the sum also, it would be O of n. So both of the things are O of n. Okay, yeah, I think you can look at the code. I had done it manually. I had not derived the formula at that time. So what I did is I sorted the array, although it would not matter if you sort or even if you don't sort, it would not matter because finally you are just getting the sum of all the elements. So taking the bigger element first or smaller actually doesn't matter. But at that time, I thought a little greedily and just sorted and took from the end. But no problem. You can do in any way. And then what I did is until the size of the array is more than 2, I just took the last element, popped the array, took the second last element, popped the array, and I pushed back x plus y minus 1. Okay, the sum of the two elements minus 1. So I just did it manually and printed the only element left in the array when the size became 1. Okay. Minus one part. Is there any minus one case here? I don't think. Okay, in the formula are you talking about? Because you start with a size of n, and after how many times do you perform the operation? In every operation, your size is decreasing by 1. So after n minus 1 operations, your size would become 1. So the number of operations performed is n minus 1. So in every operation, you can see that you are replacing with in every operation you are replacing with the sum of two elements minus 1. So finally the sum that you are getting is sum of all elements minus 1 how many times? The number of operations that you have. So you have n minus 1 operations, that's why you are subtracting n minus 1 times. Is it clear now? Okay. Okay, is there any doubt in this problem from anyone? This is one way to solve. Another way is just calculate the sum and write the formula of sum minus n plus 1. That would also be fine. Okay, and its time complexity. Obviously, that would be you are running a while loop which is running at max n times. These are all order of one operations. So this is running n times, and that's all. For input also, you are taking order of n time. So order of n and space complexity. The input array you are having of size n. So that's the space complexity. Okay, let's move to the next problem now. Problem C, XOR and triangle. Okay, this time the pink soldiers have given you an integer x. which is greater than 2. Please determine if there exists a positive integer y that satisfies the following condition. Y is strictly less than x, and there exists a non-degenerate triangle with side lengths x, y, and x XOR y. Okay. Additionally, if there exists such an integer y, output any. So what you need to do is, this time you are just given an integer x. So this time as an input, you are just given an integer x. Okay. You need to select any such y. Okay. And this y should be less than x. This y should be strictly less than x. And it should be greater than 1. So it should be in the range of, it's a positive integer, so it should be greater than equal to 1. So this basically this y should belong in the range from 1 and strictly less than x. So you need to select such an integer y in this range so that the these three values x, y, and the third value that you are taking is x XOR y. These three values should form a non-degenerate triangle. Okay, that's what you need to find. So for this x, you need to find such a y so that this condition is satisfied. And if there exists no such y, then you print a -1. And if there is some y, if there are multiple answers, you can just print any y. So the brute force approach would be just go through all the y in this range, in the range from 1 to x. Just go through all the y and check for this condition. But again, this x is 1 in 9. So if you are doing that brute force approach, it would be order of x, which would give you a TLE. So you cannot do that brute force approach. So you need to find some way to do it optimally. Basically, you need to find this y just by looking at this x. And you can see that the condition that you need to satisfy is x, y, and x XOR y should form a non-degenerate triangle. So you have a bitwise operation. So it's always, whenever you have a bitwise operation, it's always best to look the number in the binary form bit by bit. Okay, so just analyze the two numbers, analyze this x bit by bit, and try to find a y in that binary form only, which can satisfy this condition. Okay, so let's try to analyze this a little and find some answer. Okay, so let's say x is some, I'm writing this in binary. Okay, let's say you have some x. Now for that, you need to find a y so that whenever you do x XOR y, you want to find a y, and then when you do x XOR y, these three numbers should be non-degenerate. So the smaller of the two, the sum of the two smaller numbers should be greater than the bigger number. Okay, whichever is the smaller among the two should be greater than bigger number. Okay, so let's basically try to find out when can we satisfy this condition. So one basic intuition would be like 2-3 ways we can have this while. One way would be all those bits that are set in x. Let's say this y is some subset of x only, because all those are unset. I'm keeping them unset, and let's say I am setting some of the bits among those which were set. Okay, so these 5 bits were set. Among them, I set maybe some 3 of the bits in y. Okay, if I'm taking any such y, which is a subset of x, then what would their XOR be? Okay, so those bits which I set in y, they would become 0. And those bits which I left in x, they would become 1. So in this case, what would happen? This is, let's say, my z. So when I would add this y and z, their sum would be exactly equal to x. You can observe, because all those bits which were unset in x, they remain unset in all the three of them. For these bits, either it is set in x or in z, either in x or in z. So when you sum up, for this case, when you sum x and y, they would be exactly equal to x. So this doesn't satisfy our condition, obviously. And the other thing is, if I don't, okay, so this was one way to choose a y. If y is, let's say, some subset, then it doesn't satisfy a condition, our condition. So this is not allowed. One thing like we can notice. Or the other thing also we can notice, if I have some x and let's say all those bits that were set in x, I don't set any of them in my y. So all those that were unset in x, let's say I set them or maybe even leave some of them. Then also whenever I do a XOR, okay, then the sum of this x and y would be equal to this z. So the in this case we would have x plus y equal to z. So again, in this case also I got an equality, so this is not satisfied. So basically what you can observe here in these two cases, that the y I am picking, like in this case, you can like clearly observe the y I am picking was not, none of the bits were common in x and y. That is, x and y was 0 here. So if I'm picking such a y, then my condition would not be satisfied. Or if I'm picking such a y where y is a subset, for that case also my condition is not satisfied. That means I need to pick some y which is a mix of both. Among the set bits in x, I need to, in that y, some of the bits should be such, some of the set bits should be such which are in the set bits of x, and some of the bits should be such which are in the unset bits of x. If I have a combination of both of them, then only I would, then definitely I would have a degenerate triangle. Like if you have some x like this and you pick some y where maybe you, if this was a set bit, so you set that bit, and then this was an unset bit, let's say you set that bit. Okay, so if you have a combination of, in y the set bits is a combination of, some of the set bits are same with x and some of the set bits are from the unset bits of x. If you have a combination of these two types, then whatever z you get, the XOR of the two that you would get. Okay, so for this where it was set in x and you also set in y, you would get a 0 there in z. And for this where it was unset in x and you set in y, you get a 1 there. So finally, like if you see these, whenever you add two of, any two of them, okay, let's say you add these two them, these two together. So this plus this, these bits are okay, they are equal to z. This plus this would be equal to z. But for this plus this would be some extra value which is not there in z. So definitely you would have x plus y greater than z. Like for this, just by this position, in x plus y you have something extra which is not there in z. For the remaining, whatever is x plus y, it's same as z. Whatever is there in, whatever is the contribution of x plus y for all the other positions, you have in z also. But for this you have some extra. So this way you are making sure x plus y is greater than z. Okay, and the other thing was, to make sure is y plus z. So for y plus z, in this bit, as you can see, you had 1 1 which was making extra. For all the remaining bits, okay, it was not making anything extra in x. So same y plus z greater than x was also made sure. Okay, so the problem was in this case when you were taking from the set bits, then y plus z was becoming equal to x. Okay, and in this case when you were taking from the unset bits, then x plus y was becoming equal to z. But when you take a combination of the two, then x plus y also became greater than z, y plus z also became greater than z. Okay, so all both of these two conditions we were able to satisfy. And the third condition, what is remaining, x plus z greater than y, that would also be satisfied, like you can observe. So I hope this like intuition or this thing, this idea is clear to you, that we would have a y which is a combination of set bits in X and unset bits in X. Okay, so the set bits here was this and this. Okay, so this is the first intuition. Otherwise, our condition was failing. Okay, so now just you need, like, there are multiple ways to solve this problem. So I'll just discuss one of the way through which you can do is, what you can do is, whatever X you have, what you need to make sure that Y should be such so that one of the unset bits is set in Y and one of the set bits is set in Y. So what you can do is select the lowest unset bit in Y, okay, in X, lowest unset bit in X, and select the lowest set bit in X, and just swap those two bits or just set those bits in Y. That would be your final answer. So whatever X you get, okay, select the least significant unset bit, okay, and select the least significant set bit, okay, set those bits in Y and leave the remaining bits unset. So this would be one of the possible answer. This would always give you a degenerate triangle. If you take this Y and then your X or Y that you would get, so these two bits would be flipped in that, okay, and the rest of the bits would be same. So these three values would always form a degenerate triangle. Now, when would this be not possible? Would be, so let's say you have some X like this. Okay, so then you selected the least significant unset bit and you selected the least significant set bit, and that you selected as your Y. So you set these two. Okay, but in this case, this Y became greater than X. So this was not allowed. Okay, so this one extra condition that was given to you is Y should be strictly less than X. So when you have only one set bit in X, then that would be set and one other bit would be set. So in that case, always your Y would become greater than X. So in this case, for all such X where there is only one set bits, I'll say my answer is -1. It is not possible to do it. Select such a Y which satisfies this condition. Okay, so one condition for -1. One condition for -1 is if set bits in X is equal to 1. So in that case, you would say that forming your answer is not possible. Okay. And one more case where forming your answer would not be possible is when X is something like this. In this case, what would happen? If you just do that, select the least significant set bit and unset bit and set those in Y. Again, the least significant unset bit is when this bit is set, this Y became greater than X. So this Y again became greater than X. So for this also, your you would say your answer would be -1. So when your least significant unset bit, the lowest 0, is after that there is no 1. Okay, so for your lowest 0, all the ones present in the number are before that. After your lowest 0, there is no 1. Then you would say if you set that bit in Y, this Y would become greater than X. So for that case, you will say your answer would be again -1. So for these two cases, your answer would be -1. And for all the remaining cases, what you would do is select the least significant unset bit, select the least significant set bit, set those in Y. That's your answer. So I hope this is clear to you. It was a little bit more of an observation type, a constructive type, which you had to think a little bit by bit. Yeah, by test case, just by analyzing the test cases and just doing some random stuffs. In For these type of bitwise problem, you have to just look the numbers in binary and just try to observe things. Just try to do some random things and just observe bit by bit the contribution of every bit, what is happening. Just try to think a little bit in your mind, and then like some solution comes out. Mm, okay, like, is this clear to everyone, or if anybody has any more doubts, then I'll try to explain again. Okay, again. Okay. Okay, so I'll repeat once more what I'm doing here. So I'll just like, initially I had went through this intuition of why I did the solution. So let's move on to the exact solution what I'm doing. Okay, let's try to understand that why that is working. Okay, so what I'm doing here is whatever x I have been given. Okay, whatever x I have been given, what I'm doing here is I'm selecting a y so that the lowest set bit, whichever is the LSB of that x. Okay, I'm selecting two positions. One is the LSB of x and the lowest unset bit in x. Okay, so I'm from the right side the first one, and from the right side the first zero. I would select these two positions. Okay, and I would only set these two bits in my y and leave the remaining bits as zero. Okay, so if I select such a y, then my condition would be satisfied. Why? So if you observe this, if I do something like this, then what z do I get? Apart from these two positions, rest all positions would be same as x. Okay, so these positions would be same as x. And for these two positions, since for 1 where I get a 1, I would get a 0. And for 0 where I got a 1, I would get 1. Okay, so when what condition you needed to satisfy? That x plus y should be greater than z, x plus z should be greater than y, and y plus z should be greater than x. Okay, these are the three conditions that you needed to satisfy. Okay, so let's see what happens to the three conditions here. So when I look at x plus y greater than z, so for these two numbers, when you add x and y, okay, for these positions, just for these positions, let's ignore these two positions and just look at the contribution of these positions. So for these two positions, whenever you add x plus y, this z is same as x, so you would get x only. So x plus y is equal to x for these two positions, for this much of the number. Okay, this y is actually 0 only. Now, in that, when you add the contribution of this, okay, so for this x, when you add with y, the z that you get, this much is same as x, and this position is like greater than x. Okay, and this y has like 1 1. So when you add x plus y, the sum of these two, for this position 0 plus 1, you get a 1. So again, till this much number, again your x plus y is equal to z. But when you take this contribution, then in x and y, you have a set bit, so it would add 2 to the power whatever is the position there. So 2 to the power I there and 2 to the power I there. That much contribution would be there in x plus y, but in z, there is no contribution. So your x plus y would become greater than z. Okay, so you can observe when you replace one of the one with in y also you replace with a 1, then the XOR of these two, in the XOR you get a 0, but in the sum you get the sum of these two. So obviously the sum would be greater than the XOR due to this. Okay, and this thing is not affecting it. Okay, all these are not affecting it. So this condition would be satisfied because of this. Okay. And if you look at x plus z greater than y condition, then again, if you add this x and this z, then for these conditions, like this is a very big number, this is some number, and in y you have 0. So obviously these smaller bits would not matter. For the higher bits, you have some two big numbers added up, that would obviously be greater than y. This you don't need to do anything else for that, because after this, if you have any one bit which is set, its contribution would make this sum greater than y anyways. Now this is the condition that you need to check: y plus z greater than x. So if you look at y plus z, so for these bits, y is 0, so y plus z is equal to x. If you look at these two bits, for this particular bit, again 1 and 0, you get a 1. So this also, y plus z is equal to x. But for this bit, y plus z, you have 1 1, and in x you have 0. So this y plus z, its contribution became greater than x. So for this one position is making sure that this condition is satisfied. Okay. So by doing these two tinkering, you can say, I'm making sure this condition is satisfied with this thing, and with this thing, I'm making sure this condition is satisfied. And this is anyways satisfied, because we are making sure that this y is less than z. Okay, so if this y is not the maximum element, we would not check this condition, as you can notice from the previous case only. Like this, we would never check, because we know this y is less than x. That's what we need to make sure in our solution. So if y is less than x, what I told, you need to only check that condition where my maximum element is to the right. So either z would be the maximum element, so this condition need to be satisfied, or x would be the maximum element, so this condition need to be satisfied. And we know y is always less than x, so we never need to satisfy this condition if this is made sure. Okay, but we also need to make sure this. So by doing these two things, I'm satisfying this and this condition. And how I'm making sure that y is less than x? So then I checked if I'm doing these tinkering, and after this, if my y became greater than x, then I'll say my answer is -1. It is not possible to do it, because it would only happen for these two cases. Okay, so y would become greater than x for two cases. One case is when the number of set bits in x is 1. There is only one set bit in x. Okay, so if you pick the first unset bit and the first set bit and take that as your y, you know your y would be, this would become greater than x. So it is not possible. And if you just try to think, is there any way, any y that I can choose for this x to become, for this, to just satisfy our condition? Can we pick any y for this? The answer would be no, because we can understand this from this condition that whatever y you pick, if your x and y is 0, okay, so either you would pick a y where this bit is set, so you cannot pick y equal to x, you cannot pick the same number, you need to pick any different number. So whatever different number you pick, this x and y would, like, if you are picking any y less than x, definitely this x and y would be 0. And if there is no common bits between x and y, then definitely when you do the XOR, okay, whatever x it is, whatever y you pick which is less than x, when you do the XOR of these two, then your x plus y would become equal to z. X plus y would become equal to x XOR y. Okay, if there is no common bits between x and y, then your sum is same as your XOR, that you can understand. The difference between sum and XOR is, okay, when are these equal? The difference between sum and XOR would only occur when there is some common bits between x and y. So they would be equal if x and y is equal to 0. if there is no common bits between x and y, then always the sum and XOR would be equal. So your condition would not be satisfied. So it's the minimum condition that this x and y should not be 0 for us to get an answer. But for this case, when there is only one set bit, you cannot pick any y which is less than x and they have anything in common, because whenever you pick a y which is less than x, this would be unset for them and there would be some set bits in this, so their end would always be 0. So I hope you can understand why for this case you would have a -1. And same the second case where you would not be able to solve the problem by this is when you have something like this. Okay, when your first unset bit is like after your first unset bit, there is no 1 to the left. So when you set this bit, your y would become greater than x. Okay, now again for this, whatever y you pick, which is less than this, it would be a subset of this x. Okay, so if your whatever y you pick, that would have to be like these bits have to be 0 in that, your y need to be less than x. So whatever y you pick in this, whenever you do a XOR, then this y and this x XOR y, the sum of these two would become equal to x. Okay, whatever z you get, then z plus y would always become equal to x, whatever y you pick, because for these bits you would have something like this. Okay, so when you sum these two up, you would get this, because for these bits you are not doing anything. So I hope this case is also clear. When x is something like this, then y would always be a subset of x, and in this case your z plus y would become equal to x, so this would make you not satisfy your condition. So for these two cases you would get a -1. For the remaining case, doing this tinkering of first set bit and first unset bit is going to make sure that you get a correct answer. Okay, so I hope it is clear now. Let's look at the code. Okay, so first thing I check is if the number of set bits is 1, then I print a -1. Okay, so this first case, if the number of set bits was 1, I print a -1. Okay, and the other case would be handled here in the code only. So what I'm doing is in F1, I'm tracking whether I got a set bit, and in F0, I'm tracking whether I got a unset bit. So initially, I have not got them. So I start with the LSB from 0 to, these are the bits. Okay, I'll check if the ith bit is set. If the ith bit is set, okay, so what I need to make sure that I need to get the first unset bit. Okay, like one more thing, the first, yeah, I just need the first unset bit and the first set bit. Okay, so like you can, what I'm doing here is if I get an unset bit, I'm putting them in Z. Okay, so the Z that I'm writing here is actually Y. Okay, let me write that as Y only. Otherwise, you may be confused. What I explained, I'm writing the same thing in my code. Just ignore that. Okay. So what I'm doing here is when I get an unset bit, I set that in Y and put my Boolean variable as 1. Yes, I got an unset bit. And after I have got an unset bit, then if I get a set bit, then I put them in Y and I say that yes, I have got a set bit. Once this thing is done, if I have got a set bit, then I print Y. If I have not got a set bit after an unset bit, that would only happen in this case when my first unset bit would be after a set bit. After that, I don't get any set bit. So in that case, my F1 would not be 1. Then I print a -1. Okay, so there can be multiple ways to code this. So I hope this is one of the way to code. I hope this is clear. Okay, I try to find the first unset bit, and after finding the first unset bit, once I have found an unset bit, then I try to find a set bit. Okay, and if I found a set bit, that means I found both. Okay, so there can be multiple answers, as you can see. So I'm getting these answers. So is there any more doubts in this problem? By time complexity, I'm just running a loop over from 0 to 30, all the bits. So this is like log of x, you can say. And this is just if else condition. So my time complexity is order of log of x, and my space complexity is, I am not using any extra space, just these variables, which is order of 1 constant space. Okay, so uh, okay, so let's move to problem D now. Is there any more doubt in this problem? Then you can ask. I did not understand your question, Rakesh. First, no need of if two power handles separately. Okay, okay, you got. Any more doubts in this problem? Okay, so let's move to problem D now. Okay, so the pink soldiers drew n circles with their center on x-axis on the plane. Also, they have told that the sum of radii is exactly m. Okay, it's written, is this information really useful? Don't ask me, but this was the most useful information in this problem. You'll find out. Please find the number of integer points inside or on the border of at least one circle. Formally, the problem is defined as, okay, let me explain you the problem instead of reading it. So you are given n, m. So you are, as input, you are given n, m, and an array x representing the some integer points, and an array r representing the radius of those points. So what does that represent? That represent that in a coordinate axis, or it can be anywhere, you have some integer points represented by x. Okay, so some integer points are there. Okay, the array x represents those points. So this is x1, this is x2, x3, x4, let's say. Okay, they may be unsorted also. I don't think is it given sorted? No, they may be in unsorted order also, but you can obviously sort them. So you are given some integer points, and you are given some radius. Okay, so let's say r1 is 2. That means we would have a circle of radius 2 around this point. Okay, so at this point, with this point as center, with this x1 comma 0 as center, we would have a circle with radius r1. Okay, and same for x2, we would have some another circle with radius r2. Okay, circle radius of this circle is r1, radius of this circle is r2. So with x2 as center, x2 comma 0 as center, we would have a circle of radius r2. Same for every point, we would have some circle. Okay, they may have some radius, some may be big, some may be small, anything like that. Okay, so this is what we are given as input, some integer points, and every point has some radius. After this, what we need to find is number of integer points. Okay, number of integer points x comma y that lie inside any of the circle. Okay, so let's say x comma y is some integer point. Let's say this is some integer point. Then since this lies inside one of the circle, it may lie inside one circle, two circle, or anything. If it lies inside at least one of the circle, or even if it touches the boundary of one of the circle, then I'll count that point. So you just need to count how many integer points are there which are inside these circles. How many integer points inside any of these circles. Okay, the point which is outside all of the circles, that would not be counted. So how do you find out? That you need to determine. And one more, this, why was this m given? This was given that sum of the radius of all the circles is equal to m. Okay, so the radius, this sum of this array, basically the sum of this array is equal to m. And in the constraints it was given that m is up till 2e5 only. So basically this was important here, that the sum of radius of all the points is less than equal to 2e5. So you can do something in this complexity of sum of radius of all the points. That was a big hint to this problem. So now, keeping that in mind, what can we do? Let's try to think. Okay, so first thing is, if you just consider one circle, okay, any circle, it has a radius of r. So what all integer points would it cover? So let me just draw some, all the, let's say these are integer lines, okay. So when you have these integer lines, all the intersection of these integer lines which are inside the circle, they would be the one that would be that you would be counting. So instead of, like, one way to count is just consider this whole, like the brute force approach would be what? Consider this whole axis or the whole coordinate axis. Check for all the integer points present in this coordinate axis, whether they lie in some any one of the circle, and count them up. Okay, but obviously the whole axis may range up till 1e9. So that would be like from -1e9 to 1e9 is 1e10 is the range in x, and in y also 1e10. So 1e10 into 1e10, it would be 1e20. The number of integer points that exist would be 10 to the power 20. Checking all of them would not be possible. But if you just reduce it a little bit, how many points do you actually need to check? For a circle, what is the range of points that may lie inside the circle? First is in x-axis. If you have a point here, then minus, so x4 minus r4 and x4 plus r4. So like in x coordinate, this much is the range. Any point outside this x coordinate, any point outside this x coordinate would never fall inside this circle. Okay, so for x, whatever point xy we take, the x of that point should lie inside the range of xi minus ri to xi plus ri. Okay, so for every circle, your, like, the all the x that I can have for any point xy should be in this range. Now, what is the total number of all possible x that we can have? If you just try to find out, then you know that the sum of radius is equal to m. So for every circle, this range, what is the size of this range? It's 2 times r1 plus 1. That's the size of any of the range. And if you sum them up for all the I, then that would be sum of r for all the I is m. So that is 2m plus whatever, if you have n points. Okay, so this would be order of m only. The all possible x that you need to consider would be in the order of m, which is 2e5 only. That's the first conclusion. Now, your range of x is shortened up now. Now, there is also y along with that. So what you can do is iterate through all the possible x. And for that x, try to find how many y exist. Once you have fixed your x, okay, Let's say you have fixed your x, then what is the range of y for which you may get an answer? So just try to find the maximum one point. Your y would always be continuous from 0 up till some point, and from 0 up till some negative point. It would always be continuous, whatever point you pick. If you pick this x, it will be up till this upper one. It would always be continuous. So for a fixed x, you just need to find what is the maximum y that I can have. Then all the y from 0 up till that, so, and from 0 up till minus of that, this would always be symmetric. One more thing you can notice, this would always be symmetric about the y-axis. So if you just find in positive y what is the maximum you can have, in negative y also you would have the same. So for a fixed x, I can say, for a fixed x, let's say I'm telling this point as x dash comma y dash. Okay, so for a fixed x dash, if you can find the maximum y dash that satisfies, then in your answer you can just add up. If for this point the maximum y that satisfies, let's say 4, then 4 3 2 1 0, and same for the negative, -1 -3 -4. There would be this many points. So it is actually, for 4 it is actually there are 9 points. Okay, so in your answer you can just add plus equal to whatever is the maximum y dash that you can have, 2 times that plus 1, 2y plus 1. So if for a fixed x you can find the maximum y dash that you can have, then in your answer you would just add these many points for that x. So if you iterate over all the x and somehow you can find this thing in some maybe at max log n time, then m log n, in order of m log n, you can solve this problem. So let's try to find how would you find this optimally, this maximum y. Okay, so what's the condition for this y? So if you have any point x dash comma y dash, okay, the condition is also written and you can derive also. This is the condition that it should satisfy for any I. If it satisfies this for any I, your job is done. That is, the for any point, if you're whatever circle you are considering, if you're checking if this lies inside, then its distance from the center, so x dash minus xi, this square plus y dash square, this would be less than equal to ri square. So your condition is x dash minus xi, or whatever, xi minus x dash square plus y dash square should be less than equal to ri square. This is the condition. So what you need, you want to find this, your x dash is fixed and your xi ri is already fixed. So you want to maximize this thing. So your y dash square should be less than equal to ri dash minus xi minus x dash square. So basically, if you look at this thing, maximum y dash that you can get is actually, so yeah, I can say the maximum y dash you can get is ri square minus xi minus x dash square under root, whatever is the floor value of that, the integer value of that. This would be the y dash max, or you can say the max amount for all the I. Okay, you would take the max for all the I, for every I, because it may lie in any of one of the circle, it doesn't matter. So but again, if you would try to calculate this y dash for every I, that would again go order of n. You need to compute this in less time. So what you can do is, when you are moving, what are the possible I, you need to shorten up this possible I, which may for which I you may get this point, this which circles you need to consider basically. Because if you start with whichever is the leftmost circle, so what x you would start with? You would start with the leftmost x of the leftmost circle. x1 minus r1. From here, if you start with here, for this, which all circles you need to consider? This circle, you don't need to consider. You only need to consider for this circle. When you move ahead, when you cross this, then you need to consider this circle as well as this circle. Okay, so for these points, it may be this circle is your parameter or this circle is your parameter. So you would have to consider both of these circles. When you move ahead, after this, you would have to consider this circle also. When you move ahead, out of this, then this circle is no more needed to be considered. When you move ahead, after this circle is no more needed to be considered. So what you can do, you can just fix a 2-pointer of the range of circles that you need to consider and only check among them. Okay. So for the like first thing that you need to do is sort these points on the basis of their leftmost point. Sort these circles on the basis of their leftmost point. So leftmost point would be xi minus ri. So sort all of them on the basis of this thing. Okay, once that is sorted, then one by one, start with this point. Okay, and in your range, you are only keeping this x1, I equal to 1, and let's say j equal to 1. So I to j denotes the range in which you need to check, the range in which you need to take the maximum for this. These are the circles that may intercept with this x coordinate. So when you move ahead, get to the next circle, then add this to your range, increase your j. So just check if the leftmost point, if for rj plus 1, xj plus 1 minus rj plus 1. Okay, so for the next point, if this range comes before this, like I have already went through this range, then add this to your range, increase your j. Same way, just move ahead. When you cross this range, add this to your range. And once you are out of this circle, remove this from your range. Okay. So when you move in that 2-pointer approach, now at one point you may have like 5-6 circles or n number of circles also which are in this range. But overall, even if you run through all of them, your overall time complexity would not exceed m. Why? Because if let's say you have 2 circles, okay, like in this, when you are in this range, you have to check for this circle also and this circle also. Okay, but in your total x that you are considering for this, if you are checking for 2 circles, you are running 2 iterations. But uh, since there is, why you are running 2 iterations? Because there is some intersection between the 2 circles. And if there is some intersection between the 2 circles, this summation that I was talking about, that would be completely m only if there is no intersection. But if there is some intersection, some repetition, this total count would reduce. So if this total count is reducing, but for that, your count of your inner loop is increasing. This is increasing. Overall, that would become the same. Overall, your sum for even if you're running that many times, then also your overall sum for that would be at max 2m only. Okay, so I hope this thing you are understanding for the time complexity, that if you are running a 2-pointer like this and checking for all the I which are possible, if you are checking for all the I, even checking for all the I would not make your time complexity go m into n. It would not make it go m into n because your m would reduce in that case for those where there is an intersection. So your overall time complexity would be order of m only. I hope this thing is clear to you. Okay, so what's your approach is just start with the sort them according to this. Start with the leftmost point. Take your x as all the points in this range once, and as you're moving ahead, just increase your range of values that you need to consider. Okay, so I 2j denotes the range of values that you need to consider. If you're currently at I, j would be the right range that you need to the circle that you need to consider. Just keep increasing it until you can and check for all the circles in that range. Okay. And this way you can compute. This sqrt square root function would be some order of log n extra. Okay, so that is okay. It would be m log n. So it's less than log n only, or the sqrt function actually. Should we move on to the code? Is the logic clear? Yeah, you can use binary search also. Like I have got the direct formula that you can do sqrt, but you can also, instead of doing square root, you can just do a binary search and check for this condition. That would also be log n only. So if you're like not deriving this formula, if then you can just in a binary search in the check function, you can check this thing. So that is also okay. You just need to maximize your y dash for this condition. Okay, let's move on to the code now. Okay, so I took the input first. I've taken a vector of pair. So the x I'm taking as dot first, and y radius I'm taking in dot second. Okay, so I'm putting the I'm forming a pair of xi comma ri. Okay, so this way I've taken the input, so that when I sort it, I'm sorting it using a custom comparator based on this thing. What was my basis for sorting? It was that xi minus ri. Okay, whichever has this the least would come the first. Okay, so I'm sorting on the basis of this. So it would be p1 dot first minus p1 dot second. This would be less than p2 dot first minus p2 dot second. So using a custom comparator, I've sorted this vector of pair, and then I've just written my original x and r. Like you can use the pair on also. I've done just in xi, I have stored the dot first, in ri, I have stored the dot second once I have sorted them. Okay, so now I'll use xi and ri. Okay, so like how I'm writing my code, just look at this once. What I'm doing is I'm first moving on to the first circle in my sorted order. In the first circle, I'll move to all the values in the range from xi minus ri to xi plus ri. Okay, so I start with this, I'll move to all the values in this range. And while moving, I'll update the range of circles that I need to, this circle where I am currently would be the leftmost circle that I need to check. So that would be stored in I. But in J, I will update the rightmost circle that I need to check. So when I'm here, I'll just check whether this circle is in the range. If not, then I'll just stop and check for that only. So when I have moved after this, then this circle would come inside my range. Then I'll also check for this circle whether it is in the range. If not, then I'll stop there. Move ahead, move ahead. When this circle can come in the range, I'll also have this circle in the range. And once I have moved till xi plus ri, once I have moved till here, then I'll move on to the next iteration. Start with this circle. Okay, so for this circle, I'll not start again with xi minus ri. But if I have already covered till here, I'll start from here only. So my starting point would be max of currently what I have covered. X1 represents the current x and xi minus ri. So either I'll start with the leftmost point, or if I've already checked till here and then I'm moving to this circle, then I'll start from this point only. So my current value or xi minus ri, max of them. So initially I've taken my current value is minus infinity. So for the first circle, this would be considered. Okay, so this is my starting point. After that, in this while loop, I just check if, so in the while loop, I'll just run for all the values up till xi plus ri. Okay, so that was my starting point for my loop. Now I'll run until xi plus ri. Okay, so till there I'll run, I'll do x plus plus. So this is the code where I'm checking for this fixed x1, for this fixed x dash, what is the maximum y dash that I can get. Okay, I'll calculate that and add 2y plus 1 to my answer. So here I'm calculating the maximum y dash. So first I would just expand my j to the right as much as I can. So if j is less than n minus 1 and x of j plus 1 minus r of j plus 1 is less than x1. Okay, so if I'm here and the next circle can be considerable if its xi minus ri is less than my x dash. Okay, so if x of j plus 1 minus r of j plus 1 is less than x1 dash, then this j would all can also be considered. So I do j plus plus. So until that can happen, I will do, otherwise I move out of the loop. So I've expanded my right range as much as I can. And then I would just check for all the values from I till j. So I'll iterate through all the values from I till j, and I'll just maximize this y as max of y comma. What I need to maximize is this thing, square root of ri square minus xi minus x dash square, square root of ri square minus xi minus x dash square. Okay, so I'll maximize this thing over all the values, and then whatever maximum y I get, I'd add 2y plus 1 to my answer, because for a maximum y I have these many answer. If maximum y is 4, I can add 9 points to my answer. And then I do x1 plus plus, move to the next. Okay, and finally I print my answer. I hope this is clear to you. Okay, so what would be the time complexity of my code? These are input part. This sorting would take n log n time. This is a for loop of n. Okay, here I'm running this n times, and inside this x1. So overall this x1 is traversing how many times? Like even this final inside loop. Overall, I had explained you in the explanation that overall time complexity, how many times this would be executed, would be order of 2m only. Okay, and this sqrt function would take an extra, it's less than log of whatever xi. So a square root function takes less than log of xi. Log of xi is a like higher upper bound for that. It's actually more optimized than that. So, but okay, we can consider it as log of xi. That's the maximum. And this would be at max executed 2m times. Okay, so overall it would be 2m into log of xi at max. Okay, so I hope you can understand. My final time complexity would be, okay, so here we can have n log n here and plus m. So n log n plus m into log of xi. Okay, and my space complexity would be, I'm just using a vector of pair of size n. These vectors are also of size n. Okay, so order of n. Any more doubts in this problem? Okay, I think we can move to the next one now. Okay, so next problem is E empty triangle. So this is an interactive problem. Okay, what you are given is the pink soldiers hid you an integer n, like n fixed points whose coordinates are not given to you. Also, it is known that no two points have the same coordinate and no three points are collinear. Okay, so you are given n points. N points are there present, which are not given to you. And there's a condition that no two points are the same and also no 3 points are collinear. So whenever you pick any 3 points, they would form a triangle. They would not be collinear. Now, you are asked that you can ask frontman about three distinct indices, I, J, K. Then he will draw a triangle with the points. Okay. With those 3 points at index I, J, and K, he would draw a triangle and he would respond you if at least one of the hidden points lies inside the triangle. Okay. So, like if you are asking for these 3 points, this point, and this point, he would draw a triangle like this. And then if there is some point inside the triangle, okay, so like here there were 2 points inside the triangle. So if there is some point inside the triangle, then frontman gives you the index of any one of such point. Okay. He would arbitrarily select any one of the point and give you the index of that. Okay. So the index was 5 years. So he may return 5. Otherwise, the frontman responds with 0. If there is no point inside this triangle, let's say you asked these 3 points. Okay. So in this triangle, inside this, there was no point present. So he would respond with 0 in that case. Okay. So now what you need to do is using at most 75 queries, you must find any triangle formed by 3 of the points not containing any other hidden point inside. So you can use at max 75 queries. After that, you just need to find any one such triangle which does not contain any other triangle. Okay. Any other point inside it. So, okay. One major hint for this problem was this again. Hacks are disabled for this problem. Your solution would be just on exactly 35 input files. Okay, you'll understand why this was a hint for this problem. Okay, so let's discuss like this was just an information that you cannot use hacks in this problem. But what does this small information signify to you? That whatever solution you write, it may be possible that that solution is hackable. That's why like hacks were disabled here. So you just need to pass these 35 input files that would be given to you anyhow. And so basically, possibly there does not exist any solution for this, which is absolutely you are sure that for any test case that would pass. But you need to find some approx solution for this. Like this hint just gave you a little bit of that hint that maybe some absolute solution is not possible for this, but some approx solution may pass these 35 input files. Okay, so keeping that in mind, let's try to figure out what you need to do. Okay, let me explain you the problem first. So what you are given is, this is an interactive problem, obviously. So you are given n points in this integer coordinate. So there are some n points in this coordinate. So in every query, what you can do is you can ask about, you can just give 3 integers. So every index represent a point. So let's say this, and this. These 3 indexes represent this point. So the triangle that would be formed using these 3 points, inside this triangle, if there is some point present inside this triangle, the interactor would like give you that point. Okay, like it would just give you the index of that point. Then you can make another query. So in 75 queries, this n was up till 1500, and you were given that in 75 queries, at max 75 queries, you need to just find such 3 points so that the triangle formed them by them does not contain any point. So if you just randomly select any 3 points, okay, what is the worst case that can happen to you? Let's try. Okay, so you are in this coordinate axis. If you just you have many points given to you. If you just randomly select any 3 points, let's say this, and this. Okay. In the worst case, what may happen that these 3 points may contain like all the points inside. Okay. Let's suppose like all the 1500 points Okay, apart from these 3 points, whatever the 1497 points, all of them are inside this. That may happen in worst case. Okay, then it gave you the index of one such point. Okay, let's say you got this point. Then what next query can you do? If you, a little bit logically, if you think, would you just select any three random points and do a query? Would it do any benefit to you? Again, your chances of getting to your answer is still very low, because if you just select any three random points, then those points forming a triangle without a point is, the chances of getting that is low. So one thing is just select 75 random queries, just do 75 random queries. But there is very low possibilities that even after doing 75 random queries, you would get any such triangle. But you can do, what you can do is you can improve your chances a little bit by doing the queries a bit more logically. So what you can do is, once you have selected any 3 points, you did a query. It gave you a point inside this triangle. Okay. So in the next query, if you select this as one of your point and any other 2 points, what you can do is, next query you may do with, let's say, these 3 points. Then your range for your answer would be reduced to, okay, the next triangle would be in this range. So if in this triangle, let's suppose in the worst case, all the points fall in this triangle, then for the next query, either you can select these 2 points along with this and do a query on this triangle, or you can select these 2 points along this and do a query on this triangle. That also you can do. Or you can select these 2 points along with this and do a query on this triangle. So basically you can see that this point is dividing this whole triangle into three regions. Okay. So now your query depends whether you want to do a query in this region or this region or this region. But you know for sure, if there were 1500 points here, then you are just divide this uh, point is dividing it into three regions. So the worst case may happen that it is dividing them in equally, or whatever region you are selecting. Let's say out of this 1500 points, 1000 points fall in this region, 300 points here and 200 points here. This may happen. And then you are selecting either this region or this region or this region. What you would want, you would want to select a region with least number of points, but you don't get the information that how many points are there in this region. You just get the information that whether at least one point is there. So even if one point is there, you'll get that any one point. So but what you can do is, you can just randomly select any one of the regions. Then your possibility is that there is, in the worst case, if your luck is bad, you may get this region where you have so many points. You're basically, by doing this query, you didn't reduce your answer too much, but at least for sure you reduce your answer slightly, that you know. Now in this region again you get a point, and then that divides it into three regions. Then you do your next query in any one of those three regions. Okay, and then again that divides into three regions. You do your query in any one of those regions, then again you get divided. So what you can do is, among these three regions, just randomly select any one region and do a query in that. Again, next query, you get a point, divides into three regions, randomly select any one region, do a query in that. Again, divided it into three regions, randomly select any one and do a query on that. Now if I try to calculate, if this division was equal, what is the average case we can consider that uh, it would not happen that every time you are doing a query up till 75 queries. The worst case is every time, like here there were 1497 points. In the next query again, you got all of the points in that region which you selected, so 1496 still. Again in the next query all the points came in the region that you selected, 1495. So in 75 queries, you won't reach a single point. But this is the bare worst case. If you're randomly selecting any one of the region, this worst case would not happen always. Best case is in one query only you get a region where there are 0 points. But I'll always consider the average case. If you are doing something randomly, then after 75 queries, it would not happen in all the 75 queries you are getting worst case. The average case is this gets divided by 3. So it gets, you are selecting a region where you get 500 points, let's say. After that, in the next query, it gets divided by 3 and you get, let's say, 167 points. Okay, after that, it gets divided by 3 and let's say like 55 points, like that. So if you consider the average case, then dividing by 3 log base 3 of 1500, it's like around 6 point something. So in average case, in just 7 queries, you will get to a single point and you have 75 queries. So even if you consider a little worse case or even more worse case, in 75 queries, if you are doing this randomly, you would reach a single point. Okay, if your luck is not very bad, then in 75 queries, surely you would get to an answer. So that was a little bit of hint there that hacks are not allowed, because if you are if you want an absolute answer which is for sure giving you a correct answer in worst case, then this solution would be a for sure way. But in an average case or even in the worst case, like 99.9% for sure, if you are selecting randomly like this, reducing your range, then in 75 queries, you will surely reach a single point and get an answer. So, and this solution was accepted. So this was a little bit of luck and a little bit of logic that improving your possibilities, your chances of getting to the correct answer. That was it. That was the problem was about that only. So one way was just select any 3 random points always, but that was not improving your possibility of reaching your answer. But when you are doing like this, whatever point you get, then select any one random section and do your next query there. Whatever point you get, select any one random section, do your next query there. Whatever point you get, select any one random section, do your next query there. Among the 3 sections, select any one random section and do your query like this. So this way, the solution was accepted. So I'll show you the code for that. Okay, so first to get a random integer, like this is the was there in my template only, like what you can do. There are multiple ways to do it in C++. So one of the ways to do it is to get a random integer is including this. You have to write this empty 19937 this, and this inside this you have to write a seed. So once you have written this, then this R&D is going to generate a random number. Now you want a random number in the range from 0 to 012. Okay. So you need only 012. Among 012, you need a random number. So get a random number in the range from L to R. What you can do is this would then generate a random number in the range from 0 to some 118, like that range. Okay. Now with that, you can take the modulo of R minus L plus 1, whatever is the size of your range, modulo that would give you that many numbers plus L. Okay, so that way you would get a random number in the range from L to R. Okay, so this function I have written to generate a random number in the range from L to R. So I'll call that to generate a random number in the range from 0 to 2. After that, what I do is in my actual code, this scene n, then I just create the first 3 points that I take is 1, 2, 3. I start with these 3 indexes initially as 1, 2, 3 as my initial index, whatever triangle that forms. And then I'm running a infinite while loop. Then I do a query with these 3 points initially. Then whatever input I get, if that is -1, that's just a wrong answer, then I return. You can even ignore that in your code. If P is 0, that means I got a point. I got these 3 points doesn't contain the triangle formed by them doesn't contain a point inside. So I got my answer. I'll just print these 3 points. That's my answer and I return out. Okay. Otherwise, whatever I got as my P, I'll just select any one random number from 0 to 2. So if I have to select this range, what I'll do, I'll initially I had these 3 points, I'll replace this point by this point. So I'll get this range. So I have to replace any one of these 3 points by this point P. So I'll select a random index I and I replace that with P. Okay. So I'll just select any one random index among these three with the index that I got now. So that way I do the replacement and then in the next query again I'll do the next query with the new triangle. Okay, so this way in at max 75 queries, I am always getting to the answer. So this code was accepted. I hope this is clear to you. Any more doubts in this? Okay, I think we can move to the last problem of our discussion from today, if there is no more doubts. Okay, so let's move to problem F. Okay, so in problem F, what we are given is a quad tree is a tree data structure. So instead of reading this, I'll just explain you the problem. Maybe in this problem, many people would have not understood the problem only because this statement was a little bit difficult to understand. So I'll explain you the problem and then solution was more not too very tough. So you can get it. Let's explain you what the problem states. So what the problem is, like you can consider this problem like this, like you have a coordinate axis like this, and then in this you have like just forget about tree, the quad tree and all. Understand the problem like this, that in this you have some squares. Okay, so in this coordinate, or wait, let me take it there. Hmm. Okay, so you have some coordinate axis. Okay. In this coordinate axis, what you have is you have some squares, and all the squares that are present are like this. The size of the squares are always in the form of 2 to the power k, the side length. Okay. So you would have squares of 1 cross 1, then 2 cross 2, then 4 cross 4, then 8 cross 8, then 16 cross 16. Likewise, in powers of 2, the side length would vary. Okay. So if you like see 4 cross 4 squares. So from 0 to 4, this would be the 4 cross 4 square. Okay, then this would be another 4 cross 4 square. This would be another 4 cross 4. This would be another 4 cross 4. If you look at 8 cross 8, this would be 1 8 cross 8 square. Okay, and it would extend here also. Here again, you would have a 8 cross 8 square. Likewise. Okay, 2 cross 2 squares. This would be 1 2 cross 2 square, another 2 cross 2 square, another 2 cross 2 square, another 2 cross 2 square. Likewise, it would extend. So these 2 cross 2 squares would exist like this. Then 1 cross 1 square. So all the 1 cross 1 squares would exist like this. So all these, you can consider all these squares that I showed you now, all of them are present in this coordinate axis. Now, what you need to find out is you are given 4 input L1 R1 L2 R2. Okay, that represents some square. So let's say you are given, let's see one of the test case only. Let's see this third test case. Okay, so that represents, this is L1, this is L1, this is R1, this is L2, this is R2. So L1 R1 is the range of X, L2 R2 is the range of Y. So this represents this square. From 1 to 3 is the range of X. So from 1 to 3. Okay, so this is L1, this is R1, and the range of Y is also 1 to 3. So 1 to 3. So this is L2, this is R2. Okay, so it represents this square from L1 to R1 and L2 to R2. Okay, this square. Okay, so as input, you are given some rectangle, not a square, you are given some rectangle. Okay, a rectangle ranging from x1 to r1 in x coordinate and L2 to r2 in L1 to r1 in x coordinate, L2 to r2 in y coordinate. Now you need to find a combination of squares. Okay, you know all these squares are present in this coordinate axis or in this graph, whatever you say. You need to find some combination of squares, the union of which is exactly equal to this rectangle. Okay, so maybe you may take this square, this square, this square, and this square. The union of these 4 squares would be this rectangle. You need to find minimum number of squares that you need so that their union is exactly this rectangle, not anything extra. Like you cannot do something like this square plus this plus this plus this. Their union would be this thing. It would have something extra. So this is invalid. Okay. You cannot do something like you take this square in one go you can do, but you are getting these things extra. So their union should exactly cover this rectangle, not anything extra or not leaving anything. So you need to select such square. Now, you know, you cannot do for this test case. If you try to think, can you select this square? This square doesn't exist. You know, this is a 2 cross 2 square. What all 2 cross 2 squares exist? This 2 cross 2 square exists. This 2 cross 2 square exists. This exists. This exists. But no such this 2 cross 2 square doesn't exist. Okay. So you cannot do it in one go. So only option you have is take these 1 cross 1 squares. So you have to do it in 4, or like 4 squares are needed minimum. So answer for this was 4. Let's consider this test case. Here this is your L1 R1, this is your L2 R2. Okay, so for this test case, if you look, L1 R1 is 0 to 2, this is L1 R1, and L2 R2 is 1 to 5, 1 to 5. This is L2 R2. So what your square would be from L1 R1 to L2 R2? This square you would get. Okay. So you need to cover up this this rectangle. Okay. So how can you cover up this rectangle? So best way is take this 2 cross 2 square. Okay. Take this 2 cross 2 square, this 1 cross 1, this 1 cross 1, this 1 cross 1, this 1 cross 1. So in five squares you can cover this whole region. You cannot do in less than 5, like you cannot take something like this, such a rectangle doesn't exist obviously. Okay, you cannot take something like this and this because this 2 cross 2 square doesn't exist. The 2 cross 2 square that exists is this. Okay, so you can take this 2 cross 2 square, then you have to fill up with 1 cross 1 squares. So you would require 5 squares here. So for this test case, your answer was 5. Okay, I hope the problem is clear to you now. Now you just need to find out with the given constraints, LI, as up till 1 is 6. And there are 1 4 test cases. For every test case, like you cannot do This is 1e6 doesn't mean you can do some order of L or order of R. You have 1e4 test cases also. There is nothing given like sum of L. So you cannot run even O of L. You have to do it in log L or log R time. Okay. It was given like log n time something about this tree, quad tree data structure, but you can just ignore this. What I explained you, this is the problem. Okay. Now you have to solve this. So what you can do is just think how you can solve this problem. You want to find the answer for any rectangle. Okay. So what you would try for any such random rectangle, what type of squares you have? You have 1 cross 1, 2 cross 2, 4 cross 4, 8 cross 8, 16 cross 16, up till where? Like at max, its range is 1e6. So like 2 to the power 20 is about more than 1e6. So at max, you can go up till like 2 to the power 20 cross 2 to the power 20. So above that 2 to the power 21, that square would never be needed, because obviously that would cover more than the range of LNR. So your rectangle given to you are always less than this size. Okay. So at max, the type of the square that you are taking would be either 1 cross 1, 2 cross 2, 4 cross 4, like this, up till 2 to the power 20 cross 20. So there are 20 possibilities of, or 21 possibilities. Like if you can, this is 2 to the power 0 cross 2 to the power 0. So at max 21 possibilities of different squares, that different type of squares that you can take. Okay. So for any particular rectangle that you want to make, what you would try first? First, you would try that what is the biggest square that I can take out of that rectangle. Okay. So like for this problem, for this, if you try some 4 cross 4 square, like any 4 cross 4 square would exceed the length of this rectangle. So you can never have a 4 cross 4 square here. At max, you can have a 2 cross 2 square here. So I tried using a 2 cross 2 square first. So where can I fit a 2 cross 2 square? So inside this rectangle, what all 2 cross 2 square exist which are completely inside? So this 2 cross 2 square is not completely inside. This is not, this is not, this is not, but this particular 2 cross 2 square was completely inside this rectangle, so I picked that. So all the 2 cross 2 squares that is completely inside, I'll pick them, remove them, and then for the remaining rectangle, I'll again try with smaller squares, with 1 cross 1, 1 cross 1. That's the whole, like you can think this greedily, that you always have to do this only. Try from the maximum size, whichever maximum size you can fit in, just use them as much as you can. After that, go with a lower size. As you can fit in as much as you can, go with some lower size. So just you have to do this. And so what would happen? Like when you have, let's say you want to do for this rectangle, okay, whatever maximum size you did, okay, let's say you have to do it for this rectangle. Okay, whatever maximum size you can do, the maximum size you could do here was this 2 cross 2. Okay, so remove them. Then for the remaining part, just recursively call this function again for another rectangle for the remaining part, where you have to do it with some smaller rectangles. All the 2 cross 2 that you can do, they would always be in a consecutive row. So like for this, what 2 cross 2 can you do? Your starting point, your this L1. Okay, if this is divisible by 2, okay, then there would be a 2 cross 2 square starting from here. Okay, where do the 2 cross 2 squares start? It starts from 0 to 2, okay, then 2 to 4, then 4 to 6. So 0, 2, 4, 6, all the starting points are divisible by 2, and all the ending points are also divisible by 2. Same if you consider 4 cross 4 squares, all the starting points are 0, 4, 8, they are all divisible by 4. Ending points are divisible by 4. So just by looking at your L1 and R1, can you determine which is the first 2 cross 2 square that would be completely inside? Okay, so for this L1, if it is divisible, then there would be a 2 cross 2 starting here. And if not, then whichever is the next best integer point which is divisible by 2, a 2 cross 2 square would start from here. Same for the ending, which is the rightmost point where a 2 cross 2 square would end, that you can determine. So you got an L and R. Same for the Y range you can do. You would get a L and R for a Y range. And that way you would get all the complete 2 cross 2 squares that you can use here. Once you have got that, then it would be something like that. Uh, Okay, so let's say you wanted to calculate for this rectangle. This point was L1, this point was R1, this was L2, this was R2. Okay, so let's say you wanted to cover this rectangle. Then you first tried with the biggest that you can. Let's say that was 4 cross 4, let's suppose. Okay, or anything 2 to the power k cross 2 to the power k. For some k, the biggest that you tried that could fit in, let's say it was this some 4 cross 4. Starting from here, you got a 4 cross 4, then another 4 cross 4, and another 4 cross 4, and same way, let's say. Okay, so the covering that you got was like this. Okay, so let's say these are some 4 cross 4 squares. Okay, so in this whole rectangle, you were able to get these 4 cross 4 square completely, and all these remaining parts here you were not able to fit any more extra 4 cross 4 rectangles. So what you can do is, how many such exist? First of all, how would you find this? After L1, like after L1, which is the first point which is divisible by 4. Let's say it was this point. Let's name it as LL1. This was the first point which was divisible by 4 just after L1. And just before R1, which is the first point divisible by 4, it was RR1. Okay. So this was the first point divisible by 4 just before R1. Same for L2. The first point just above L2 divisible by 4. This was LL2. And the first point just before R2 divisible by 4, it was RR2. Okay. So with this, what you got is this much you can cover with 4 cross 4 squares. And how many 4 cross 4 squares would be needed? This length divided by 4 would give you 1, 2, 3, 3. And this length divided by 4 would give 2. So 3 into 2 equal to 6 squares were needed. So this way you were able to compute that a total of 6 squares were needed to cover this much range with 4 cross 4 squares. And you cannot fit in more 4 cross 4 squares, because like if you try to fit in more 4 cross 4 squares, it would go out of the range. Same in all the sides. Okay, so once you have computed this, then you can recursively say that my answer would be, okay, my answer would be, how many 4 cross 4 squares you got? 6 4 cross 4 squares, plus for the remaining area you need to recursively call a function. Now your function is calculates the answer for a rectangle, but this area is not a rectangle. So first of all, you have to cut it into different rectangles. So what you can do is, this would be one rectangle. Okay, this whole area would be second rectangle. This is third rectangle. this is fourth, this is fifth, this is sixth, seventh, eighth. So you can always, after selecting a range, you can divide this rectangle into 8 different rectangular regions, and you can recursively call your function for all these 8 regions. Okay, you will get their coordinates through this. So recursively call your function for all these 8 regions, knowing the fact that if you have used 4 cross 4, you can only use 2 cross 2 at max. Okay, so if you have used 2 to the power k cross 2 to the power k, you will use 2 to the power k minus 1 cross 2 to the power k minus 1 at max next, or if that is not possible, then even lower. Okay, so I'll just create a recursive function with L1, R1, L2, R2, and X, which represents the maximum size of the square that you can take. So I'll say that this recursive function is equal to, first, through using X, just compute these using the modulo and all, just compute these LL1, RR1, LL2, RR2. Through this, get this rectangular region and the size of this, like here you got 6. Now, what would be the formula for this? RR1 minus this length divided by X. Okay. So RR1 minus LL1 divided by X multiplied by, so 3 here and 2 here, 3 cross 2. So 2 was this difference divided by X. So RR2 minus LL2 divided by X. So this is for the current, how many 4 cross 4 tiles you got. This many 4 cross 4 tiles you got. Plus you would call this function recursively for 8 of those cases. So like for case 1, 2, 3, all the 8 rectangles, you will call this function recursively for all these 8 regions with x by 2. Okay, so here if you had x cross x squares, now you would have x by 2 cross x by 2 squares. So like one of the example, if you want to call for this region, it is from L1 to LL1, L2 to LL2. So you will call from L1 to LL1 and L2 to LL2. I think L2 to LL2, L1 to LL1 with x by 2 as the maximum square size. So this way you will call those 8 functions recursively, and this way you can solve this problem. Your base case would be, if some range, let's say by dividing while dividing this square falls here. So this L2 and LL2 would be equal. So basically this would not form this part, these parts would not exist in that case. So what would happen is, if in my function my L1 and R1 become equal. So if in my function my L1 becomes equal to R1, or if L2 becomes equal to R2, if either this, there is no difference between these two or no difference between these two, that means I have an empty rectangle. The area of the rectangle is 0. That rectangle doesn't exist. So then I can just return 0. Okay. So this would be my base case. Okay, so this I can say is my base case, and this is my transition. So this way, if I recursively call my function, then at max, how many recursions it would go? At max, I would start with 20. I would start with x equal to 20 in every step. Okay, so if I try to compute the time complexity, at max, I'll call the function for x equal to 20. Then with this, at max, there would be 8 more functions. At max, I'll have 8 more functions, but there I would have x by 2. Okay, so with 20, I would have 19. Okay, and then from here again, for all of them, at max, I'll have 8 more partitions with 18. It would not go always 8, 8, 8, because Lengthwise also you are dividing. Okay. Lengthwise, if you are using like in the next transition, if you have used this square and you are dividing it into 8 other regions, then if like you have used 4 here, then this length is less than 4 for sure. Okay, then again if you are dividing them, so lengthwise at max log n times only you will like divide and go. At max 20 times it would happen, and breadthwise also at max 20 times. So maximum possibility would be like 20 into 20 only. Okay, like this recursive tree, the depth of that would go up till 20, and the length at max would also not exceed more than 20, because at one time these parallelly all the rectangles that you are calculating, that won't all of them would have some different range of lengths and heights. Okay, so at one time if you are running parallelly a lot of recursions, then some of them would become 0 and it would end up with the base case. At max, like you can say it would be divided into 20 parts only. So at max your or not 20. Okay, at max it would be the length, which would be like L, the range of L, which was 1e6, I think. um okay. Okay, I think it would go 20 only. Just a second. Yep. Yeah, you can understand it like this. When whatever length you have, let's say you have 1 is 6 length. Okay. So if you just consider lengthwise, what partitions you are, it is happening. First, for 2 to the power 20, if some rectangle is possible, you will try. Okay. Then if you are using a rectangle, it would reduce your length by more than half, obviously, because if it was not possible to fit in a rectangle there, that means the space here was less than 4, the space here was less than 4. Okay, so all of these would be less than that length. So at max always you are dividing by like less, it's less than half, less than half, less than half. So at one time parallelly, if you are having a lot of functions, then maximum you would have is this 20 into 20. So this breadth would go at max 400. Like this breadth would go at max 20 cross 20 of this recursion tree, and this length would go at max 20. So it would be like 20 cube only, which would is 8,000. Okay, this multiplied by 1e4 test cases would also give you 87. So this would be accepted. Okay, so I think it is clear to you. So using this recursion, you can just break this thing just using recursion like this. I'll move on to the code now. Okay, so what I'm doing here, I have just created the function which I'm just calling and printing. This function returns me the maximum number of squares required for L1, R1, L2, R2. I'm starting with the maximum square size I can have is 2 to the power 20. Okay, I'm starting with x is equal to 2 to the power 20. Now in my function, I write the base case. As I had explained, this was my base case. If L1 equal to R1 or L2 equal to R2, then I'll return 0. Okay, and then I try to calculate these values. For this particular x, what is the first value just to the right of L1 divisible by x, first value just to the left of R1 divisible by x, Same way, just to the just above L2 divisible by X, and just below R2 divisible by X. Okay, so for LL1 and LL2, I have to find the value just above L divisible by X. So there can be two cases. If this L1 is divisible by X, if this is already divisible by X, then it would be L1 only. And if it is not divisible by X, let's say L1 is 5 and X is 4. Okay, so then the next multiple of 4 is 8. So what you can do is L1 mod X, here 5 mod 4 was 1. So or what you can do, just below, if you want to find divisible by X just below L1, then you do L1 divided by X multiplied by X. If you do the integer division of that, 5 by X, 5 by 4 would be 1, multiplied by 4 would be 4. So integer division by X multiplied by X would give you the value just below 5 divisible by X. And since 5 was not divisible, if you add X there, so if you get 1, if you get 4, in 4 if you add X, you get 8, the next value. So if it is divisible, L1 is L1, otherwise it's L1 by X into X. Okay, so L1 integer division X gives you, multiplied by X give you the value divisible by X just below L1. If you add plus X, you get the value divisible by X just above L1. Okay, same for L2. If it is divisible, then same L2, otherwise L2 by X into X plus X. Okay, and for R1 and R2, for R1 and R2, you need to get a value just below R1 divisible by X. So you can just directly write R1 divided by X into X and R2 divided by X into X. So you got LL1, LL2, RR1, RR2. Then just write these transitions. Okay, so one thing is, if you are not able to form a if you are not able to form any shape with this, then what may happen, that your RR1 becomes less than or equal to LL1. This means you don't get a range, you don't get a rectangle. Or if RR2 becomes less than LL2, that means you don't get a rectangle. So you just call the same function and reduce your size by 2. Okay, you were not able to do using 8 cross 8, so you tried 4 cross 4. If that is not possible, then you would try 2 cross 2. So you will just call X by 2. And if there is something in this range, then some rectangle is formed here. Just calculate the size of this rectangle using this formula. So using that formula, I calculated the size of the rectangle. This into this, that's what I did. And along with that, recursively call these 8 regions. Okay. So I just recursively called these 8 regions. You can see L1 to LL1, L2 to LL2, L1 to LL1, L2 to LL2. So this first region covered. Then the second region would be LL1 to RR1, L2 to LL2. Okay. So LL1 to RR1, L2 to LL2. Same way the third, fourth, fifth, sixth, seventh, eighth region. I have written all of them. Along with that, I've called them with X by 2. Okay. So this way I recursively call the function and I just got my answer. Okay. I hope this problem was clear to you. So thank you so much for tuning in. Goodbye.